Hello students, this is Tejesh from 2Pi Academy. In this video, we are going to have a recap of all the formulas in straight lines. All the formulas discussed in this video are available in the PDF format in our Telegram channel. Please check the link in the description. So let's get started. First we have coordinate geometry basics. So first the distance formula. So consider you are given 2 points Px1, y1 and Qx2, y2. Then the distance between them is given by square root of x2 minus x1 squared plus y2 minus y1 squared. That is change in x squared plus change in y squared. And one special case is that the distance of a point Px, y from the origin 0, 0 is given by square root of x squared plus y squared. Just have to substitute the point x, y and 0, 0 in this formula. And then we have the section formula. Section formula is mainly of two types, dividing internally and externally. Dividing internally is used to find the point that divides the given line segment internally. For example, consider 2 points Px1, y1 and Qx2, y2. And in the case of dividing internally, the point R divides it in between the line segment. So here if you observe carefully, R is in between P and Q. And let's say R divides PQ in the ratio m:n, that is PR is m and QR is n. In that case, we have the coordinates of R as mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. And one special case of dividing internally is the midpoint, which is a point that divides the given line segment into two equal parts. That is in the ratio 1:1. And the midpoint of x1, y1 and x2, y2 is given by x1 plus x2 by 2 and y1 plus y2 by 2. And then we have dividing externally. In this, the point divides the line segment externally. That is, if you see this image carefully, you observe that the point R is outside of the line segment PQ. So let's say P is given by x1, y1 and Q is x2, y2. And let's say R divides PQ externally in the ratio m:n. It is also the same thing as before. It means that PR by QR is equal to m by n. And the point that divides P and Q in the ratio m:n externally is given by mx2 minus nx1 by m minus n and my2 minus ny1 by m minus n. The same as before, but instead of plus we have minus. And then we have the area of a triangle. Let's say a triangle is formed by 3 points A x1, y1, B x2, y2 and C x3, y3. In that case, the area of the triangle formed by these points is given by 1/2 into the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. And this determinant can also be represented as 1/2 into modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. And now let's start with straight lines. We have the inclination of a line. Inclination of a line is nothing but the angle that the line makes with the positive direction of x-axis in the anti-clockwise direction. That is this angle right here. And the inclination of a line is usually denoted by the letter theta. And then we have the slope of a line. This is also called as the gradient of the line, and it tells how inclined the line is. And it is usually denoted by the letter m. And if theta is the inclination of a line, then m is nothing but tan theta. And some important points to note are that for horizontal lines, the slope m is 0. And for vertical lines, the slope will be not defined because vertical lines means theta is 90 degrees, right? Tan 90 is not defined. And for parallel lines, we have m1 is equal to m2, the slopes will be equal. And for perpendicular lines, m1 into m2 is equal to -1, that is the product of the slopes will be -1. This can also be interpreted as the slopes are negative reciprocals of each other. m1 is -1 by m2 and m2 is -1 by m1. And then we have slope using 2 points. Let's say you are given 2 points on the line x1, y1 and x2, y2. Then the slope is given by y2 minus y1 by x2 minus x1, that is change in y by change in x. And then the angle between two lines. If you consider two intersecting lines, they will have two angles between them. One of them will be acute angle and the other will be the obtuse angle. And if theta is the acute angle between two lines, with slopes m1 and m2. The slope of the first line is m1 and the second line is m2. Then we have tan theta is equal to modulus of m2 minus m1 by 1 plus m1 m2. And now if you know the acute angle, you can easily calculate the obtuse angle, right? It is nothing but 180 minus theta. Then we have collinearity of points. 3 points are said to be collinear if they lie on the same straight line. Let's say if A, B, C are collinear, then slope of AB will be equal to slope of BC will be equal to slope of AC. That is, the slope of any 2 points on the line is the same. And there is also another way to calculate this. If ABC are collinear, then the area of triangle ABC will be 0. And then we have the forms of straight lines. Equation of straight line can be represented in various forms. First, the basic ones are horizontal and vertical lines. So horizontal lines are nothing but lines that are parallel to x-axis. And the equation of these will be of the form y is equal to a, where a is a constant. And the vertical lines are lines that are parallel to the y-axis. And these equations will be of the form x is equal to b, where b is a constant. And then we have the slope point form. This is nothing but y minus y1 is equal to m into x minus x1, where m is the slope of the line, x1 comma y1 is the point on the line. It can be any point on the line. And then we have the 2-point form. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1, where x1 comma y1 and x2 comma y2 are 2 points on the line. If you observe carefully, the 2-point form is the same as the slope point form, with the only change being that instead of m we have y2 minus y1 by x2 minus x1, which is nothing but the slope of a line when 2 points are given. So therefore we get this by substituting this in place of m. And then we have the slope intercept form. In slope intercepts there are 2 types. First, by using the y-intercept and by using the x-intercept. And generally slope intercept form refers to using y-intercept. And using y-intercept we have y is equal to mx plus c, where m is the slope of the line and c is the y-intercept, that is the point at which the line cuts the y-axis. And when using x-axis we have y is equal to m into x minus d, where once again m is the slope and d is the x-intercept, the point where the line touches the x-axis. And then the intercept form, x by a plus y by b is equal to 1, where a is the x-intercept and b is the y-intercept respectively. And then we have the normal form. It is also called perpendicular form. It is given by x cos alpha plus y sin alpha is equal to p. And in order to understand what p and alpha are, let's see the following graph. Here this is our given straight line, and here p is the perpendicular distance from the origin to that straight line, or in other words the length of the normal from origin to that line, and alpha is the angle that the normal makes with the x-axis. And then we have the distance form or the parametric form. This is given by x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r, where x1 y1 is a point on the line and theta is the inclination of a line and r is the distance of x comma y from x1 comma y1. That is, if you take any point on the line, the distance of that point from x1 comma y1 is given by r. That is why this is known as the distance form. It tells the distance. And there is an important application for distance form, that is, if you want to find the coordinates of a point on the line that is r units away from x1 comma y1, use the following formula: x1 plus r cos theta comma y1 plus r sin theta. The general equation of a straight line is given by ax plus by plus c is equal to 0, where a, b, c are constants. And an important concept is reducing to general form. So for example, let ax plus by plus c is equal to 0 be a straight line. Then to reduce to slope intercept form, we first take x and the constant terms to the right hand side and divide both sides by b. By comparing this with y is equal to mx plus c, we get slope as minus a by b and the y-intercept c as minus c by b. And then we have converting to the intercept form. To do that, we first take the constant term to the right hand side and divide both sides by the right hand side, which gives us the following equation. By comparing this with the intercept form, x by a plus y by b is equal to 1, we get the x-intercept as minus c by a and the y-intercept as minus c by b. And then the normal form, this is a little complicated. Let ax plus by plus c is equal to 0 be a straight line. To convert this to normal form, we first take the constant term to the right hand side and divide both sides by square root of a squared plus b squared. And one thing to remember is that in the normal form, the right hand side denotes the length of the normal. And you know that length can only be positive, right? So here if the RHS is negative, you have to multiply the equation by -1. And by comparing this equation with the normal form, we get cos alpha as plus or minus a by square root of a squared plus b squared. As we said before, if it is negative, we have to multiply by -1, right? So it can be either plus or minus. And sin alpha is plus or minus b by square root of a squared plus b squared. And you know that cos square alpha plus sin square alpha is always 1, right? And that is true in this case. Finally, we have p is equal to minus or plus, it will be opposite of cos and sin, c by square root of a squared plus b squared. And then we have position of points relative to a line. Let's say you are given a straight line ax plus by plus c is equal to 0 and 2 points a x1 y1 and b x2 y2. And you need to find the position of a and b relative to the line, that is whether they are on the same side of the line or different side. To do that, we calculate ax1 plus by1 plus c and ax2 plus by2 plus c, that is substitute these points in the line respectively. And if both of these have same sign, it means that the points are on the same side of the line. And if they have different signs, it means the points are on the different sides of the line. And there is a simple trick for equation of parallel and perpendicular lines. We said before that the slope of parallel lines is equal and slope of perpendicular lines are such that their product is -1, right? Or if you are given the equation ax plus by plus c is equal to 0, the line parallel to it will be of the form ax plus by plus lambda is equal to 0, only the constant term changes. Lambda can be any constant. And the line perpendicular to it will be of the form bx minus ay plus lambda is equal to 0, where once again lambda can be any constant. And then the distance of a point from a line. And distance of a point from a line refers to the perpendicular distance of that point from the line. For example, consider a line ax plus by plus c is equal to 0 and a point p x1 y1. The distance of this point from this line is given by modulus of ax1 plus by1 plus c by square root of a squared plus b squared. So for the numerator, you have to substitute x1 and y1 in the equation of the line, and for the denominator, it is square root of a squared plus b squared. And a special case of this is the distance of origin from a line. Origin means 0, 0, right? Substituting this, it should be 0 plus 0 plus c. So the numerator will be just c and the denominator is square root of a squared plus b squared. And then the distance between parallel lines. This refers to the perpendicular distance between these two lines. And let's say the equations of the lines are ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. As we have said before, for parallel lines, only the constant term changes. Distance between these two lines is given by c1 minus c2, change in the constant terms by square root of a squared plus b squared. Once again, don't forget the modulus. Distance can only be positive. And then we have the point of intersection of two lines. So let's say a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are two lines. Their point of intersection is given by b1c2 minus b2c1 by a1b2 minus a2b1 and c1a2 minus c2a1 by a1b2 minus a2b1. Or you can get this by solving these equations using cross multiplication method. So you get x by b1c2 minus b2c1 is equal to y by c1a2 minus a1c2 is equal to 1 by a1b2 minus a2b1. And then we have concurrency of three lines. Three lines are concurrent if they pass through the same point. So let's say the following are the three equations of the lines L1, L2 and L3. If they are concurrent, then the following determinant will be 0. And another thing is that if three lines L1, L2 and L3 are concurrent, then lambda 1 into L1 plus lambda 2 into L2 plus lambda 3 into L3 will be 0. That is, if you multiply the three equations by some constants and add them, you get 0. And then we have the foot of the perpendicular. So let's say there is a point P x1 y1 and a straight line ax plus by plus c is equal to 0. The foot of the perpendicular refers to the point where the perpendicular from this point to the line touches the line. And if P x1 y1 is a point and the straight line is ax plus by plus c is equal to 0, then the foot of the perpendicular is given by x minus x1 by a is equal to y minus y1 by b is equal to minus ax1 plus by1 plus c by a squared plus b squared. And then we have the image of a point. This is also known as the reflection of that point in the line. So let's say a point is P x1 y1 and the line is ax plus by plus c is equal to 0. Then the image is given by x minus x1 by a is equal to y minus y1 by b is equal to minus 2 into ax1 plus by1 plus c by a square plus b square. This is the same as foot of the perpendicular, but only this 2 is the difference. And one thing to remember is that the foot of the perpendicular is the midpoint of a point and its image. You can see here, right? The foot of the perpendicular divides the point and the image into two equal parts. And some particular cases of the image are: first, the image of a point along x-axis is x1, minus y1. The y coordinate will be the reciprocal and the x coordinate the same. And along y-axis is minus x1, y1, the opposite. And along y is equal to x is y1, x1. The coordinate will be interchanged. And then we have family of lines through intersection of two lines. So let's say two lines are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Then the family of lines that pass through the intersection of these lines are given by a1x plus b1y plus c1 plus lambda into a2x plus b2y plus c2 is equal to 0, where lambda can be any constant. And then equation of a line using point and angle with another line. Let's say you need to find equation of lines that pass through x1, y1 and make an angle alpha with y is equal to mx plus c. Then the equation of that lines will be y minus y1 is equal to m plus or minus tan alpha by 1 minus or plus m tan alpha into x minus x1. Here if you notice carefully, there is plus or minus and minus or plus, right? This is because there are two possible lines that satisfy these properties. And then we have the angular bisectors. Angular bisectors of two lines are lines that split the angle between them into two equal parts. Like see here, the blue lines are our given lines and the angular bisectors split that angle into two parts, right? Both of them are theta. And every pair of straight lines have two angular bisectors between them. Like there are two angles between lines, right? Each bisector bisects each of the angles. And these two bisectors will be perpendicular to each other. And there is a simple condition for the slope of angular bisectors. So let's say there are two lines with slopes m1 and m2 and the slope of the bisectors be m. Then we have m minus m1 by 1 plus m into m1 is equal to m2 minus m by 1 plus m into m2. You notice this is nothing but the angle between two lines formula, right? So angle between the angular bisector and the first line will be equal to angle between the second line and the angular bisector. And if you solve this, you get two values of m, each of which corresponds to each of the angular bisectors. And then the equation of angular bisectors. Let's say two lines are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Then the equation of the angular bisectors of these are given by a1x plus b1y plus c1 by square root of a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 by square root of a2 square plus b2 square. That is the first equation by the square root of a1 square plus b1 square is equal to plus or minus second equation by square root of a2 square plus b2 square. And then let's say you need to find the bisector of the angle that contains the origin. Any pair of straight lines have two angles between them, right? And one of those angles will contain the origin, right? And we need to find the equation of bisector that passes through that angle. To do that, first we will obtain the two equations of the lines, which are the following. And then we rewrite them so that the constant terms are positive. Both c1 and c2 should be positive. If they are negative, multiply that equation by -1. then the bisector of the angle containing origin is the bisector corresponding to positive sign. So here we have plus or minus, right? If you take the plus, in this case, we get the bisector of the angle containing origin. And lastly, we have acute and obtuse angular bisectors. As we said before, a pair of straight lines have two angles between them, right? One of them will be acute and the other will be obtuse. And let's say you need to find the acute and obtuse angular bisectors separately. To do that, we use the following procedure. Once again, let the straight lines be the following and rewrite the equation so that the constant terms are positive. But in the third step, here we find the sign of a1, a2 plus b1, b2. If it is less than 0, that means it is negative. The acute angular bisector is the one corresponding to the positive sign and the obtuse is the one corresponding to the negative sign. However, if it is greater than 0, it is the opposite. Minus corresponds to acute and plus corresponds to obtuse. These are all the formulas you need to know in straight lines. Once again, this is all available in PDF format in our Telegram channel. Check out the link in the description. And thanks for watching. Be sure to like and subscribe so you don't miss any future uploads.